Sure, sir. Thank you so much. So, my voice is audible to all of you?
Yes, yes, yes.
Okay, sir. Thank you. So, in the last session, we had completed some of the topics regarding the introduction of IoT and the basic coding concept. So, let me start with my last presentation so that we can just pick up some initial points to conclude the last session and start our today's new session. So, let me share you the PPT. So my home screen is visible to all of you. So you
Yes,
can
it is
see that.
visible.
So it's you can see that at the first session we understand the history and the need of IoT concept in our day-to-day life. So we discuss about the applications, so application areas where we can use this concept and make some new products to solve some problems faced by the people. And next, we have studied about the development boards for IoTs. There are so many development boards are available in market, but we discuss about the most of the using most of the you can say that the most preferable development boards by the developers of the schools and colleges. So the next thing is we started with the Node MCU, and our next topic will be the Raspberry Pi, which will be considered by tomorrow. So we was just working on Node MCU development board and how to start or how to initiate this Node MCU development board in our uh, basic projects. So we started working with this by putting the firmware to code it in embedded C language. Then we go for the libraries that we should need, add some libraries to work with so that we can make some basic projects like blinking of LED by third party server Blynk app. And we also came to know how Blynk app works and how to interface it with Node MCU development board. So at the last time, we were discussing about the analog sensor, interfacing of analog sensor, that if you want to get some data of analog sensor on any server, so how to interface it. So we was discussing that and at the last point, and the practical was pending because of the time. So today we will go further with that last topic, that how to uh, get the sensor data on Blink app. So let us start with this. So firstly, I want to show you, this is our Node MCU development board, and it is connected with the through the USB to my computer. And you can see that there is only a single analog pin. If it is visible to you, that is A0, where my finger is pointing. It is there is only a single analog to digital converter pin. This that is the ADC pin. So what does the ADC mean? So it is all about converging the voltage value to a digital value. Voltage is an analog value provided by the sensors to the microcontrollers, and the microcontrollers convert it into the digital form. So as we were discussing about that, most of the sensors are available in the market with three configurations. Maybe you can get the voltage sensors, which can provide you the voltage range from 0 to 5, and you have to calibrate that values into the digital form so that you can get the actual or understandable values. Like we have the temperature sensor LM35, suppose. So when you make its circuit and interface it with any development board, or you can say that the Node MCU development board, so it gives you the output from 0 to 5 volt. So according to its data sheet, LM35 sensor provides you the range of 0 to 5 volt output, and it is compared with the 0 to 100 degrees centigrade temperature. So it means 0 to 5 volt will gives you the calibration value according to the 0 to 100 degrees centigrades. So how to calibrate it, or how to get these values, or how to convert this voltage into the digital method? So we need a development board which should have the analog to digital converter pin. So in the node MCU there is a single ADC pin, that is why we are using this pin for connecting the voltage sensors. So if you want to measure the temperature of a room, and you want that it will be shown to you on a Blynk server or any third party server, so what you have to do, you just have to connect the voltage output pin of that LM35 sensor with the A0 sensor or A0 pin of the node MCU. After that you have to write a code, and code was like that: you have to add initial libraries that are ESP8266 Wi-Fi.h and Blynk simple ESP8266.h. These two libraries are must included in the code so that we can use their functions, inbuilt functions. And next thing is, you have to add the authorization token. We already discussed about it in the last session, that what is the role of authentication code. So you have to put your authentication code here, and your network name here, password name here, means SSID and password of the hotspot to which you have to connect your node MCU. The next thing, we have to write it in the void loop, because there is only a single pin of ADC. So what we have to do, we just have to read it first. So I will take a variable here, suppose int a. So I will assign it the value of the analog pin. What will be the reading of the analog pin? It will be stored into the this integer type variable a. So how to write it? We just have to write analog read a0, because a0 is the naming and number, no, you can say the nomenclature of analog pin of the node MCU. So you are reading the A0 pin, and whatever will be the value read by this pin will store to the this integer variable A. So now what we have to do, we will send this value stored in the A integer. So this value will go to the Blynk server by writing a command, that is the Blynk Blynk dot virtual write virtual write, and after that the small brackets, and in the small brackets you have to write the virtual pin number. That is, suppose you can start with the 0. Suppose I am taking the virtual pin 1, and after that comma, and the value which you want to represent on that virtual pin. So I will tell you the concept after this, that what virtual pins means about. So firstly I will put,
Gaurav, please
yes,
increase the size of your font. Please increase font size. Some people are requesting if it is possible at your end.
okay sir. Okay, so is it really visible now?
Yes, yes. Now good enough. Good enough.
So, so this command we have to write so that we can send the analog read value to the Blynk virtual pin. So what is the virtual pin? Basically, it is a variable defined by the Blynk server. As we have declared there int a, it is a user defined variable which is defined by us, so that we can assign any readed value into the this a integer. So what we are doing, we are just putting this value stored in the a variable to the Blynk virtual pin. So virtual pins are the basically a variable declared by the Blynk app or Blynk server. So we are just sending this value to the virtual pins so that we can go to the Blynk app and find out a widget where we can show our uh, analog read value, and we just have to select the virtual pin on the Blynk app. So further I will show you how to interface it. So these are the two lines which we have to add, and what we have to do next, just compile it. So if there will be no error, so we can go directly to the upload section so that we can upload the code into the node MCU. So it is telling us that there is a error of semicolon. So here we have to put an semicolon and go to the upload section. So you can also get your errors here on this screen and clear them by checking that errors. So it will take some time to upload because in the background of these libraries the code is very large. It is taking more time. Okay, it starts uploading now. So it is showing us error about some COM4. Okay, so while it is uploading, let me take you to the Blynk app, that what changes we had to made on Blynk app. Okay, so my mobile screen is visible to you now. Okay, so last time we take analog read values, but I will change the widget to the analog gauge. So there is an option about analog gauge. So you can see that the gauge. So it will show you the like the as analog meter works. So what we have to do, we just have to click on this gauge widget, and on the pin option we have to choose virtual pin. So we will go for the virtual and V1 because we have choose V1 as the virtual pin in the code. So click OK on this. On the other hand, my code is uploaded into this ESP8266 module. So we didn't add our authentication code and SSID and password, so it will not connect it to us. So let me just add it into the code. So this gauge will show you the output of the analog read pin. Let me give you the output by adding the authentication code and SSID and password. So I will start my hotspot now so that my Node MCU development board can connect. So you can see the tethering or hotspot active, and here you will get the notification when my Node MCU will connect with this hotspot that one active user is connected. So I have added SSID and password and authentication code in the code. So it is uploading. Yes, sir.
Gaurav, just an interruption. Mallikarjun Gowda is asking that if you can uh, share your code on chat box, then they can exactly try at the same time.
Okay, okay, sure, sir. Actually, I can share only one screen at a time. So let me share you. Okay. Now my screen is visible.
Yes, 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 it is visible.
Okay. So let me show you from the start. If anyone want to note down and if anyone want to get the output from Node MCU on their mobile phones, so even they can uh, get this code. But if anyone want to note that value or if anyone want to observe that value on their phone, they need my login credentials for that. So let me write on the notepad so that you can. Okay, let me write here. So the credentials are Anmol Bhagwaj 108 @gmail.com, and the password is Anmol 800. So try these credentials to log in the Blynk app so that you can get the same notifications or same output of sensors on your mobile phones. So that you can even verify that it is working on over the internet. You can get the sensor value from anywhere. Okay, so is it write down or you need some more time? There is a void setup and after that there is a void loop function. Let me take it down so that you can write rest of the code. Here you can change your SSID and password according to your mobile hotspot SSID and password. This is mine. And these are the basic lines which you have to add to read the sensor value. Okay, sir, fine. Can I go for the further steps? Hello.
Yes, sir.
Okay, sure. Even I will share this code to you. So now I will connect my Blynk app. So you can see now this is the Blynk app from the mobile screen. So you can see that it is my device is showing that it is continuously connecting and disconnecting here. So what will be the problem for this? So you have to know about the functionality of Blynk app, that how it works. As we write two line of code in the void loop means which the lines which we want to run repeatedly in the loop. So we write that lines in the void loop function. So by writing that two line code in void loop, this type of error is occurring in my Blynk server. So in a while time it is showing this that device is active, and on the other hand within a few seconds it is showing that it is disconnected. So it is due to the function called in void loop. I will show you on the computer screen. So this error can be removed by a adding of a timer function so that it can be work parallelly. So how to add these function into the code? Let me share you the screen again. So this error can happen if you add these lines into the void loop. That's why I am showing this error so that you can thoroughly go through it. So I will show you the timer functions so that we can add the timer function and void loop. But this error is coming due to these two lines. If I will remove these two lines, this error will be uh, resolved, because this blink dot run function needs to be alone in the void loop function. If you add any one of the line and it takes some microseconds to read this lines, but this microsecond delay can make an stop or delay to this blink dot run function to execute. That is why these two lines are an hindrance for this function to work properly. That is why blink dot run function should be alone or should be write individual in the word loop if you want to process these two lines at the same time. So you need to write a timer function for here for making this parallel processing. Let me show you how to add this. It isn't just simple function which you can add and use it parallelly. Okay. No, it's not here. It is taking much more time to operate because there are so many libraries are included. So when we start this Arduino Uno software in our computer, so it initially is all the packages we have already added. So okay, so here is the first thing what we have to add. We just have to add first this line to our void setup function. So it is telling that timer dot set interval 1000L my timer dot event, so my timer event. So basically to create a timer event we have to write this. It will this function is used to set the timer interval, that at what time interval it would repeatedly make that function active, the timer function active, so that the output or the code lines written in that timer function can be executed. And another thing, we have to call the timer dot run function here also. So where is the timer function written in this? I will show you. It's okay. So this is the void my timer event. This is the code, or this is the function of timer function which we have to add. So let's start adding in this in our code. Firstly, what we have to do, timer dot set interval function will go to the void setup here. Next, we have to write the timer function. As we have write my timer event here, you can give any name to this timer function, but with that same name, you have to add here.
Gaurav, again increase the font size. It is not
Sure, sure.
exactly visible. Yes.
Okay. So first line we have to add is timer dot set interval, that at which time interval that timer function should call and repeat itself. So next thing is the we will call the timer function here also. It is the name of the timer function. So firstly we have this add this line into the void setup function to create the time interval, and after that we will write a timer function here like this. So what we want to write in the timer function is that two lines. We just have to minimize it. Okay. So these two lines here so that it can process it. And after that, the last thing is we have to call a function here that is time dot run function. Timer dot run function. So just these things we have to add. Now the error of connecting and disconnecting the node MC development board with the Blynk app will remove and it will go smoothly. So now we have to upload this code. So it will take time. So on the other hand, I will take you to the Blynk app now. You can see our code is uploading. So after uploading, the error of connecting and disconnecting will go. Okay, it is taking some time to upload. These practicals will help you to make some projects and start with it. It is taking time to upload. Okay, now uploading is done. So when we will play this project, now you will see that test is connected and no disconnection problem is showing here. Now it is showing us a garbage value because no sensor is connected with the A0 pin. So now I am going to connect A0 pin with ground so that it will show the exact zero. Okay, it is showing the 1024 value. One thing we have to set here that it should go from the 0 to 1023 and it should be the push button of it. Okay, so I have connected my A0 pin with the 5 volt. So it is showing you the maximum value, that is 1024. If I connect it with the 3 volt, so it between the middle. Okay, let me give the range about that. So for that purpose, we have to calibrate it between that what should be the value of uh, at the 5 volt and what should be the value of 3 volt. We have to calibrate it in the code so that we can get the value of analog to digital converter. But when I connect it with the voltage, so A0 when connected with the voltage 5 volt, it shows you the maximum value like this. And if I connect it with the ground, it show you the minimum value, that is mine 3. If I connect an sensor which gives the value between 0 to 5 volt, it will gives you the exact digital value according to that sensor. So this is the interfacing of analog sensor with it. I will show you the some next part, that how we can control our uh, home appliances like 220 volts with this node MCU development board. So I will show you a PCB or a development board designed by us so that you can get the exact information. So if it is visible to you that I'm showing you the PCB, it contains 4 relays, means you can control 4 for your home appliances which will be operated at 220 volts. Or here you can you will connect your node MCU development board here, and what we have to do to make it possible that if you want to control your home appliances with the help of node MCU and these relays, so that you can switch your home appliances. So this is the basic circuit at the behind. So I will share you the every details so that you can make a project at your own. So what we have to add on this, firstly we will know about the relay. Basically the relays are electromechanical device, means it is triggered by a electrical or electronic pulse. You can basically voltage pulse. Maybe you are already known to this component. So there are many, basically two types, or even you can say that on the demands, there are many types of relays are available in the market. But basically SPDT and DPDT relays are available for maximum of the applications. So SPDTs are single pole and dual throw, like this. You can see this is the single pole, means there will be a single common pin, and these are the two throws. One is the normally closed and one is the normally open. It means this common pin will by default connect with this normally closed pin, and these are the two coil pins. If this coil is energized with some voltage, so this connection will break and com this pin will connect to the normally open pin internally. So it works as the electromechanical switch. So you can see the schematic that when this winding get accelerated, So this switch common pin is connected to the normally closed pin in the by default position. But if it is energized by a voltage, it will disconnect to the normally closed pin and connect to the normally open pin. So this coil will energized with low voltage like 5 volt, 12 volt, 6 volts, and these normally closed and common pins can handle the 220 or 240 volts. So what we have to do, and what type of circuit we need to make. Let me take you to the Proteus simulations. By simulating, you can get the benefit results even. So firstly, this is the simulation part where you can see the pin diagram and the whole circuit. So firstly, what we have to do, we have to add the components here, like relay. So this is the relay. We have to select it. One, we should need some resistances. So I will write the RES to add resistances. Or we maybe we need some optocouplers. ET187 will help us, and it will need some DC547 transistors also. Okay, so this is the basic requirements to make the relay circuit. Okay, so firstly we will put our relay here. Let me zoom it in. So you can see these are the pin diagram for relays. This is the winding pins, and these are the common, and this is the NC, and this is the NO pin. So you can change the excitation voltage for this relay. If you want to excite it with 5 volts, so you can just click here, so and change it to the 5. After that, what we have to add, it is PC817. This is an optocoupler IC. Basically, it is used to isolate the circuit of microcontroller and the circuit of relay. So that, because as we know that this is an inductor, or this is it behaves like a coil, these inductor pins. So when we excite them with some voltage, it generates the back EMF. That is why that back EMF should not harm our microcontroller. That is why we use the optocouplers or opto isolators between the relay circuits and the microcontrollers. So now the next thing is BC547. So what we will do, we will make a Darlington pair here like this, and this pin will goes to the one pin of. Okay, let me change this position so that it can directly connect with this pin. Okay, so now this pin of transistor, this is the emitter pin, will goes to the one pin of relay, and another pin will goes to the ground. So we will take ground here. Okay, so now this is the part of relay, and this is the part of microcontroller. It means one ground will go there, and it will connect like that, and this pin will goes to the microcontroller. And I will add a button here. So I will go to the component mode, and add a bulb to show you the output. Okay, so this is the lamp active. And one thing we can add, that are the logic operations. So I will add the lamp here. So what should be the connections? Like if you have the 220-volt connections, it will go to through the same connection diagram. So I will add here a sign, means an AC power. This is an AC power. Here we have to add RMS value 220 volts, frequency of 50 hertz. It is just for simulation, but it will not need it in the practicals. So it will give this 220-volt line, and for neutral we will take a ground. Okay. So one connection of bulb will directly goes to the ground, and another connection will go to the anode pin and on the second pin of the bulb. So I will click here and change this voltage to the 220 volt. So this is the circuit diagram. Take it as the two-pin socket, that one is the line and another is in neutral, and make this connection with your relay and the bulb. And this is the basic circuit needed to accelerate the or energize the coil of relay so that it can switch. So you can see that when there will be a high logic input, means 5-volt input will be provided by the microcontroller here. So LED will blink, and this transistor of my optocoupler, it will be in active region, and it will push this transistor also in the active region. So the voltage coming from this collector pin will go through the uh, emitter, and it will go through the coil of the relay, and it will energize, and it will go through the common pin will connect it to the NO pin. So now I have to add the power. This is the VCC needed for relay 5 volt. So this is the basic circuit we need to design a home automation project. So logic state. By connecting logic state here, I can just give the command, that is the high logic and low logic, by clicking on this. So this is the basic test circuit. So when I play it, okay, the 5-volt rail supply is failed. I just have to change it. I will take the DC component here. Make it easy. Okay. So now it is in the play mode. So if there is a zero logic, the bulb is off. If there is a one logic, my optocoupler is in working state, but this transistor is not in the active state because of the component. Okay. My relay is trigged. You can see here it is now disconnected from the uh, NC pin to the NO pin. Let me show you the once again. If I will click on this logic state, it will turns to 0, and this connection should disconnect from NO and goes to the NC pin. Let me show you the. You can see here your relay is triggering, but your bulb is not showing the blinking. So let me take any voltage here. Let's stop. Okay, it was blinking, I think. No. Let me take here 12 volt. Okay, so you can see here now it is blinking. So the same feature or the same circuit will use with the node MCU development board, as we have already made a code for the switch in the Blynk app, that when we press the button from the Blynk app, and the pin will gets high. So if I will connect this circuit to the D4 pin, and I will use the same switch uh, added in the Blynk app. So when I will click on this button, my uh, relay circuit will be in the active region and in the inactive region by clicking on this button. So you can create your uh, home automation project by using this circuit. You can even note down this. This part of the IC will go to the microcontroller pin. It will go to the D4 pin of the node MCU, because node MCU library is not included in this practice. Otherwise, I will able to show you the actual experiment. So, is it note down, or shall we go further? Hello. Hello.
Yes, you may go. No participant response.
Okay, okay, sir. So now the next thing is, and the next question may arise in your mind, that what type of protocol is used by the Blynk app, because uh, every server has their own protocols to get or receive the data or post some commands from their server to the hardware. So what type of protocol used by the Blynk app? So the answer is, there is a mixture of MQTT and HTTP protocol. So they made their own protocol for their own server to make it reliable, more reliable. So as I told you in my first session, that you can even make your own protocol to send or get the data from hardware to server and server to hardware, by taking any protocols, like there is MQTT, there is a HTTP, and there is a FTTP also. So you can make your own protocol for your own server. So they use the mixture of MQTT and the HTTP. But according to the updations of Blynk community, they are discussing to, or they are trying to change their whole server to the MQTT, based on MQTT protocol. So maybe in coming days, it will be totally dependent on the MQTT protocol. But it is nowadays they are using the mixture of MQTT and HTTP protocols. So these are the basic functions, and these are the basic things that you can made from Blynk app and Node MCU. So what will be the next thing? I will just show you the one more server where this is that are the ThinkSpeak. As you can see that Blynk app gives you the opportunity to make a projects, like if you want to control by this by your project by app. So it gives you that allowance. But if you want to get only data from hardware to the server, the graphical representations, and you want that graphical representation data can stored in that server also. So ThinkSpeak will be the best option. Let me show you the screen. Okay, it is already showing. So these are the ThinkSpeak. Let me initiate it with first point, how to start with ThinkSpeak. Okay, so for the first condition, if you want to use the ThinkSpeak, the need you must have the MathWork ID. So if you don't have the MathWork ID,
Mr. Gaurav, sorry for interruption. Can you maximize the screen? Some candidates are asking.
sir, it is already maximized.
The
Maximize that screen.
font is very small.
Okay. Let me make it zoom.
Okay. Thank you.
Okay. So there are the another third-party server which is free for a while. You can only save your data up to 3 to 4 months on ThinkSpeak in a freeware. So if you want to store it for like for a year or for 2 years, 3 years, you have to go for with their student packages, and even there are so many packages available on this three ThinkSpeak. So firstly, if you want to go free, you should have the MathWork account to use this. Wait. Okay. So if you don't have, you can go to the create one option. But I already have a MathWork account, so I will directly enter to this ThinkSpeak. You just have to add your ID and password. By signing in, your MathWork account will connect with the ThinkSpeak. Okay. So this type of user interface will be appear on your Windows screen after logging in, and you can see here there is a option of new channel. So if you want to send the data from a hardware to the ThinkSpeak server, and you want to check that what instance you are receiving that data, so you have to create a channel for this. So we will go for the new channel. So you can see that there are so many options available here. You have to fill it up. Let's start filling it by us. So let me take the my project name as a test. Okay. So after that, you can create a description here if you want to. Otherwise, you can skip this part. So another thing is the field label. So how many fields you want to add in your channel? Fields will be like the graphs. So how much number of graphs you need to add in your channel? So there are options available here, field from 1 to 8. So you can maximize add 8 fields in this channel. So let me go further with some field 1. You can even change this name, like you can change it with the name of sensor data. Okay, so you can even add more fields by clicking on this tick button. So if I only need one, so I will go with this. So nothing will be have to add in the metadata tags. Simply okay. So now come to the last point, that save channel. So now your channel is saved with your basic configurations, and you can see there a field chart is appearing on your screen. So here you will get the sensor data from the Node MCU hardware or even any IoT development hardware. We just need to add code in that particular development board, and the sensor data will come to the this field, and it will show like a graph, and it will show you the graph between sensor data and the time date. So you can even change this to the another things, like if you want to see your sensor data and between the, like if you want to get the voltage and current graph, so you can change this date portion to the uh, current option, and the sensor data will go change to the voltage option, so that you can create a VI graph here. So it can be happen by editing this field chart by clicking on this option. But if you want to get only sensor data here, so it will show you the according to the time, that at which time sensor data is available on this field chart. So after that, what we have to do, we have to you can see even what will be the public view if you share this link, the link of this channel with your friends and partners. So what will be the public view you can see here. Okay, so because you didn't make it as a public channel, so that is why the public view will not available. So it is in the private view, so you can just check it out in the private view. So if you want to change it in the public, you can go to the settings and can change this. So what we need from the things speak, the main thing we need, that are the API keys. So this is the API keys. You can see the write API key and read API key. Both are different. Means if you want to send any data from any development board to the ThinkSpeak, you have to use this API key. And if you want to read that data, which is available on the ThinkSpeak, or you can say that available on your field chart, and you want to retrieve them, so you have to use this API for that particular uh, code. So these APIs will help you to get the data or post data on the ThinkSpeak. So I will tell you that ThinkSpeak server works on the HTTP protocol. So HTTP protocol is a simple protocol which based on the post and get method. Means if you want to get the data, so you use the get command, and if you want to post some data, you use the post command. So basic fundamental of HTTP protocol is that there will be a link of ThinkSpeak and your API key. It will help your development board to log in on the ThinkSpeak server and put their data onto the ThinkSpeak server. So these API keys have an important role, as in Blynk app, the role was uh, authentication, as authentication key have a role in Blynk app. The same thing in the Speak server, the API keys are working in the same process. So what we have to do, as you can say that the API request here, so you can get the information about get commands, that if you want to get some data from the ThinkSpeak server, you can go with this API link, and you just have to add your API key here. So these are the basic things about the ThinkSpeak server, and how to start it with ThinkSpeak server. You just have to add some libraries here. I will show you that what type of libraries you need. As you need some Blynk libraries to work with the Blynk functions, so that you can easily start up with some projects. So if you want to work with ThinkSpeak, you as well as you need some ThinkSpeak libraries here, so that you can use their functions to make an code in as an easy way. The difference between Arduino and the rest of the microcontrollers are that you just need to use the functions declared in the libraries, and you just have to know about the functions of that libraries. But in the rest of the microcontrollers, you have to write each and every line at your own. So it will be a very it needs some more time to write that things or write each and every line to work accordingly. So the to start a project with an IoT, so working with an Arduino IDE is best. So here you can see that ESP8266 Wi-Fi.h that already is in my library folder. You need a Wi-Fi client.h and ThinkSpeak.h library here in extra mode, as you need to send the data from this node MCU development board to the ThinkSpeak server. So what changes in the code you need? Firstly, the two libraries uh, it will be needed for the sending of data. After that, the SSID and the password. Visible. Let me make it zoom to you. Okay. So the channel number, you can get the channel number in the settings from the ThinkSpeak and your right API key. As you have, I already told you that there are two API keys. One is the right API key and another is the read API key. So the AI right API key you have to add on this place. So let me take you to the ThinkSpeak, and what we need a channel number and the API key. Let us take this right API key, copy this API key and paste it into this place. So another thing is there should be a channel number here. So it will be in the settings of the ThinkSpeak. So channel setting, go to the channel settings, and here you will get the channel ID. So just copy it and put it here. So next are the here we take an integer variable of 8 bits, sorry, 8 bytes. So you can see here it is named with some force. So you can even change this because force is our sensor name. So as you can change it to the simple a variable. The next thing is you need to serial begin the you have to add the serial begin function for the serial communication protocols so that it can serially communicate with your node MCU. After that, Wi-Fi.begin and SSID password. This command will be written in that void setup. Why it is needed? As in Blynk app, you can see here that Blynk.begin function was used, which is already defined in the Blynk simple ESP8266.h library. So what it does, it just get the values from authentication key, SSID and password from this part and put these values or these properties of the SSID or variables to the Blynk.begin function, so that it can initiate our node MCU development board, or it can even connect our node MCU development board with our hotspot. So as same in this code, Wi-Fi.begin function is doing. So it is doing the same job it takes the SSID and password and put in this function Wi-Fi.begin to connect our node MCU with our hotspot. So here it is just checking the one more thing, that if Wi-Fi dot status is not equals to WL connected, means if your Wi-Fi is not connected with your node MCU, so it will show you the this dot 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 until unless it is get connected with your Wi-Fi or hotspot. So after connecting with hotspot, your node MCU will return Wi-Fi is connected on the serial monitor. So it is the serial monitor. Here will be you get your outputs or your these serial print lines here, that is your hardware is connected or not. After that, ThingSpeak.begin function is called as we write the Blynk.run function in the while loop. So it is doing the same job in this code. After that, there is the no limitation of adding the code line into the void loop, because for ThingSpeak server, it does not need to be any another timer functions. So you can just put your code lines into the void loop here. So what we have to do now, we just have to put A. So what will be the value of analog read A0 pin? It will be stored in A. Now we have made some calibration here by using this line, but I will remove this because it is not required at this time. So what will be the output of A will send to the my write API key. So you can see this there is a link created by this function, that ThingSpeak dot write field, your my channel number is called here, the one A, and A is the value of variable, and my write API key, which I have already added in the starting function. So this is the all about the coding part, or the basic thing you need to add in the ThingSpeak code. So after that, you just have to upload this in your Node MCU development board. And after uploading, you will able to get the values on your field chart, which is on this page. So we made a delay of 3 seconds in this code. You can see here there are 3 second delay. So it means after a span of 3 seconds, your updated value of A will send to the ThingSpeak field chart. So you can change that delay according to your requirement. So Blynk app and ThingSpeak have different uses and different approaches. So you can use them according to your requirement, or you can use them according to your project requirement, what your project need to do. So you can go with them. So it is taking time to process the code or upload the code. If there will be no errors, it will just upload it simply. So you can see that it is uploading the code. Okay, so the uploading is done. Now we will go to the ThinkSpeak chart and see that. So now my node MCU data is connected. So you can see that the first input, so first output from the sensor is arrived, and you can see the time and date also. So uh, after time span, you will get the values here. So if there is no change, it means your sensor value is not updating. So we have to update our value. So you are getting just 2 or 3 as you were getting in the Blynk app. So you can see that as it get updated, the next value come with value 9, and you can see the graph from 2 to 9, and it gives you the time and the date also. So it can record your data up to 3 to 4 months for freeware. But if you want some more time to store your data, so you can see that after the time span, it is showing you the data on this field chart. So you can get it the in the form of uh, graph. Even you can share your this page to your friends and your customers even, so that they can observe the output of the sensors data. But you just have to change your channel settings here. Suppose we will go to the channel settings, and we will make it to the public view. Wait, just wait. Okay, so there are the options: keep channel view private, or share channel with view with everyone, or share channel view only with following users. So you can add some emails here, to which you just want to share your this page. So if I click on this share channel view with everyone, so now I will go to the public view. So you can now see the public view. Public can see this page only. So if I want to share this, we just have to click on this link, copy, and just have to paste. Let me share you with on Google Meet. Okay, so you can even get the same value on this link. You can even try it. So this is all about the ThinkSpeak and Blynk app. These are the free servers. So if you are if you want to make a project on based on IoT, so I will suggest that a group of person can do many more things. If some people from CSC and some people from electronics background, they if they uh, make a group, and if they work togetherly, so they can made up many more projects or many more products, because CSC person knows how to build a server, or how to build a you can say that the cloud, and the electronic person knows that what type of hardware should be there, and what type of the coding should be there in the node and or in the any development board. So by combining their ideas, they can make so many projects. Even it can be live. So I will suggest that make some projects by combining your ideas, so it can create a revolution in the market also. and it is the need of nowadays. As I was just watching the ad in a TV, that it was about the washing machine, because after the COVID-19, you can see that the days of COVID-19, after the days of COVID-19, they have made that washing machine based on IoT. So they shows that a police officer comes to their home, and they directly doesn't meet their family, and he just go and change their clothes and put it into the washing machine, and his wife just start up the machine with the help of mobile phone and just an app created by the washing machine company. So it is now the need of the society, because everything is or everything will be going to be wireless or touchless even. So everybody wants some updations, some controllings, or some commands from anywhere or any location. So it can be a revolution in the upcoming 2 to 5 years. So I will conclude my today's lecture here. So if anyone has some queries in their mind, so they can go with them and ask me.
So, participants, if you have any query, please ask. No response. So thank you,
So
Gaurav ji, for
thank you so much,
nice
sir.
presentation. I think you have cleared all the thing. That's why no query is there. Hmm.
Sure,
Very
sir.
informative session you have
Thank you so much,
delivered.
sir.
And
Even tomorrow, I think we have two more lectures.
yeah. One is tomorrow, one is day after tomorrow, the last
Uh,
session of
yeah,
the
actually, sir, it was rescheduled by tomorrow. So the
okay.
both lectures will be on tomorrow. One is from 12 to 1:30, and second is the 2:30 to 4.
ओके 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 अच्छा वो एक्चुअली दैट्स भाई वो उनका ह्यूमन वैल्यूज की वजह से थोड़ा सा
Yes, sir. Yes, 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 sir.
ओके ओके सो थैंक यू अगेन
Thank you so much, sir.
थैंक यू तो थैंक यू पार्टिसिपेंट्स और
Thank you, sir.
वी विल मीट टुमारो थैंक
Okay,
यू
okay. Thank you, sir.